Hello guys, welcome back. This is the playlist in which we solve WASSCE past questions. In this playlist we are doing elective mathematics. 2016 is the year of this exam. This is paper 2, question number 2. We solved question 1b in the previous video. So the question number 2 says find from first principles the derivative of f of x is equal to x plus 3 all squared. Okay, let's go to the sketchboard or the workbook or whatever it is you want to call it. So we are finding the derivative from first principle. Now allow me to underline first principle. I'm going to explain this after we have solved this and really try to give you a difference between that and when they don't sorry, the difference between when they say differentiate from first principle and when they don't say that. All right, so we are trying to find the derivative from first principle f of x of f of x f of x such that f of x is equal to x plus 3 whole squared. Okay, now before I go on, I want to give you an intuitive understanding of what it means to find the derivative of something or to differentiate something. Let's say you have these two axes not drawn to scale. This x-axis of mine is the straightest line ever, believe it or not. Unless, okay, and let's say this is another very straight line, not drawn to scale too. Alright, now if we were to find the slope of this line, say from this point to this point, so let's say x1 here, y1 here, x2 here, y2 here, right? So the slope will be y2 minus y1 or y1 minus y2, but just make sure it follows x2 minus x1. This gives the slope. So you can see that this finds the difference in the two y values. Let's call it delta y divided by the difference between the two x values. Let's call it delta x. This gives the slope, and this will give, because since it's a straight line, it's going to give you a specific value, right? And for this line, it's going to be positive because it is this way. If it were this way, if the line were coming downwards, it will be negative. All right, we know this stuff. Okay, so what I want you to recall is that for a straight line, once you calculate the slope, if you take any x values at any point, any x and y values at any point, and then you calculate the slope using these points, you're supposed to get the same answer that you just did here. Just if you find this y minus that y divided by this x minus that x, you still find the same slope as a single value. No questions about it. If you find the slope at this point, you get the same answer. If you find the slope at this point, you get the same answer. If you find the slope at this point, you get the same answer. It is the same slope on the straight line. Is that clear? Okay. Now, let's say we no longer have a straight line. Our line is no more straight. Instead of a straight line, we now have something like this. Okay, now what if you are asked to find the slope of this curve? Because it is a curve now. So let's say at this point, you have, remember that you you only find the slope between 2 points. That is why when I was drawing the straight line, we have this. So from this point to this point, we find the slope, right? So let's say you find a slope between this point and that point. See, x1, y1, x2, y2. You can do that, but if you find the slope here, that will not be the slope of this curve. Make no mistake. That will be the slope of a straight line from this point to that point. Yes. And if you were to find the slope at this, from this point, between this point and that point, that will be the slope of a straight line between that, joining them, and so on. So clearly you can see that the slope at any 2 points on this curve cannot be the same throughout. So wait, how then do we find the slope of a curve? Now, if you are expecting to find the slope to be a single number, sorry, bad news, you can't do that. What we can do, however, alright, is this trick. Now watch closely. I'm just going to redraw a curve, not drawn to scale. And then, let's bring the points very close to each other. So that you see that small little curve right there, it now looks as if it's now very close to a straight line. So that if we were to draw the line, those 2 points are more or less on a straight line. Let's say this thing I've drawn right here is a straight line. So we have x1, y1, and there's x2, y2 there. Okay? Alright. So we have this. Now, at the next 2 points, there's another slope that we can find there. And at the next, so you see that there are lines, right? Now, if you were to calculate the slope of each of these, you find that the slope will actually be changing, right? If the slope of this one were, say, m, and this will be like m plus something, plus 1, this m plus 2, this m plus 3, and so on. The slope will be changing. What I want, not just increasing by 1. It's not always the case. I just want you to realize that the slope will always be changing whenever you calculate the slope from any point on the curve. Is that okay? So what we are interested in when it comes to a curve is not just to find the slope, because you won't find it to be a single number. No. But we are interested in finding the change in the slopes. How does the slope, the value of the slope on the curve change? So maybe if it were m here, then m plus 1 here. We see that, okay, so the slope is changing by increasing by 1 unit. You know, the more you move upwards the curve. Okay, so that is the kind of change, the kind of slope that you'll be interested in for these kind of curves. And such kinds of slope, we say you are finding the derivative. The derivative of the curve. So usually the derivative will now give you an expression. Let me just, so the derivative will give you an expression that helps you track the change in the slope. This you must really understand, what is happening here. So in a straight line, we just find the value of the slope, which is supposed to be a single number, whatever it may be. But when it comes to curves, we can't find a signal because it will be changing, right? So but we can actually track the change. So that change is what we can actually determine. How does it change? So finding a derivative means find an expression which gives us an idea about how the slope changes along the curve. And that is what the derivative is. So now that you've understood that, let us now try to answer the question. I'm just going to go through the pain of cleaning this up without touching the top. Okay. So they said f of x is equal to x plus 3 squared. Now I use the x and y axis to illustrate this. Anytime you want to solve these questions, try to picture them on x and y axis. Even if you don't know how the shape of the curve will be, just picture it as a curve on some x and y axis. All right. Okay. So based on that, you find that we can that means since this expression is in terms of x, this implies y will be equal to x plus 3 all squared because x. So we can let y be equal to that so that this value on the x-axis will evaluate to a value on the y-axis which you can actually plot. Okay. So of course, as you can see, the first thing we can do is to basically expand it so that we can see the equation clearly. So y is equal to x squared plus 3x plus 9, which is equal to, I'm trying to do it basic, 6x plus 9. Alright, so this is not yet the solution, this is just simplifying the stuff. Alright, so now to differentiate from first principle, right, it means that, as I said, to find an expression from this that gives us an idea about how the slope is changing, right? Now this means that, just let me quickly draw the x and y axis for a moment. So let's say this curve, this is a parabola, so it probably looks something like this. I don't know, I'm just drawing. Okay, so, and we have y, x, and something of that sort. Remember that for the slope, it is changing y over changing x. You know, remember that you find the y minus y1 over x2 minus x1. So this is what we call changing y over changing x. Okay, and then of course this will give you the slope, right? So we are basically going to do the same thing, but knowing that this is not going to give us a single value, but it will give us some kind of expression which gives us the change. All right, so knowing this, we know that whenever x changes, so whenever there is a change in x, there will be a corresponding change in y, because of course the equations are like this: y is equal to x something something. So when there's a small change in x, there should be a corresponding change, small change in y. Now that is the expression, that is the assumption behind differentiating from first principle. So as part of your solution, it is important to write what I'm about to write. Okay, so we say let a small change in x give rise to a small change in y. Okay, now there are some dogs barking, and then I think this video is gone quite long enough, so I want to pause this video and then return to continue from here. Okay? Alright, see you in the next video.